All right, everybody, we are just about finished with our look at polynomials, and we need a video about the zeros of polynomials. So we've been looking at things like the remainder theorem and the factor theorem and how to know if something is a zero of a polynomial. We've done division, long division, synthetic division, stuff like that. But now we need to know, well, if I'm going to do synthetic division, how do I know which numbers to even pick? That's the question, right? So what I've got here is general form of an equation where the power is x to the nth, right? So the power is the nth power. So this can be any polynomial, and they're going to, in general, be things that are larger than x squared, because if it was just x squared, we could just use the quadratic formula, right? So in these, what we see is we need two things. One is the leading coefficient. Okay, and that just simply means the number that is out in front of the term with the largest exponent. So x to the nth is the largest exponent here. So I want this a sub n. So whatever that number is there, okay, the coefficient. Okay, and then I need to know what the constant term is. Okay, and that's going to be some number at the back, if there is one, that has no x attached to it, right? And technically, if we wanted to deal with the x's, it could be x to the 0, right? That's a 1. So that means it's just a constant sitting out there, just a number, okay? And if I have this, then what I know is this. I can list out all the possible rational zeros. So again, rational, see that word ratio in there. Okay, so these are going to be fractions. I can list out all the possible rational zeros that are anything that's possible for a solution for the equation. It can be listed as all the factors of the constant, whatever that guy is, all the factors of the constant, divided by all the factors of the leading coefficient. Okay, and that's just a little math process that we'll do, and we'll list out all the stuff. So this is what I'm after. I need to know the last guy that doesn't have an x with it, and I need to know which term has the largest exponent, n in this case, so that I can find the leading coefficient. And I'm going to take all the factors of the constant and divide them by all the factors of the leading coefficient. So that'll tell me all possible rational zeros. And then once you have the list, this will give me a list. Once you have a list of possible rational zeros, well, then what you're going to do is you're going to use synthetic division to find out which ones are zeros. Okay, or whatever other technique I have, but normally for us, it's going to end up being synthetic division. Okay, so I need these possible rational zeros first, and then I'm going to use some of my little tools that I've put into my tool bag now to figure out which ones are the ones that I actually want. All right, so in order to see this easier, what we're going to do is work a few little examples that are going to help me see stuff. And the first thing is not working through all the way. We're not going to solve yet. We just need an example that helps me figure out how to use this possible rational root theorem to begin with. Okay, so here's an example. It is f of x equals negative x to the 4th plus 3x squared plus 4. And the directions are going to say something like this. List all possible rational zeros. So list them all. What is possible? And then later we will see, okay, now that I know the possibilities, how can I work with this? Okay, so what I need to know is what's the leading coefficient. So here's the biggest term, right? The biggest exponent. So I need the leading coefficient. Well, it's whatever number is in front of the x to the 4th. It's a negative, but we know there's technically a 1 sitting there, right? So negative 1. And I need the constant term. Constant is 4. Okay. I need those two things in order to be able to figure this out, okay? And what it said was, in order to list all the possible rational zeros, I needed to write all the factors of the constant, divide by all the factors of the leading coefficient. So that's what we're gonna do, okay? So factors of the constant. So my possible zeros are rational zeros. So the reason it's important to keep on saying the possible rational zeros is because what if it's something like the answer is square root of 3 or something like that? Well, that's not a rational number. I'm not going to be able to find that using this method, right? So the idea would be try to find the rational roots first, and then once I reduce my x to the 4th down to something like a quadratic that I can work with, then I'll be able to deal with, oh, okay, so what's left over is these things that I can find the square root of using quadratic formula or something like that. Okay, so all the factors of the constant. So it could be 1 times 4, or it could be 2 times 2, right? And all of these could be positive or negative. So in other words, if I wanted to get a 4, I could do 1 times 4, or I could do -1 times -4. And we don't know which one we're after, so we have to put the plus or minus out there, okay? And divide by all the factors of the -1. Well, that's got to be a plus or minus 1, right? Because it's got to be 1 times -1. So I need both of those in there. Okay, those are all my possible rational roots. And then the next step is, so number 1, list all these constant guys. These are the factors of the constant. Divide by, these are the factors of the leading coefficient, right? Okay, so use the little thing that we have set up there. Okay. Figure that out, get this list, and then the second thing you need to do is simplify. Okay, now this one's not going to be horrible for the simplification because they're all divided by plus or minus 1. Well, we know that a whole number divided by 1 is just that whole number. So I've got plus or minus 1 divided by 1 is 1. Plus or minus 4 divided by 1 is 4. And plus or minus 2 divided by 1 is a 2. Okay. So there's all my possible rational roots. And that's all that is. We're just asking you to list all the possible rational roots. And then we'll go from there and figure out what we can do. Okay, so which ones work, which ones don't, that kind of thing. So here's an example for you to work on. Take a second, pause the video, whatever you need to do. My example is, and it's the same direction, so list all possible rational roots. And what we'll notice is rational zeros, I'll say, since that's what they're using in the book. What we'll notice is all of these things can be simplified down to be either whole numbers or they look like a fraction, right? So the function is f of x equals x cubed plus 2x squared minus 5x minus 6. So we're not solving it yet. All we're doing is listing all the possible rational roots. So off to the side, and you can pause it if you want to work on it and then see what I do. Off to the side, I'm going to say, well, my constant is a -6. I'm just making sure that I got what I'm looking for. And the leading coefficient, I'm trying to be lazy here and not have to write all this out. Sorry. That guy, well, it's whatever's out in front of x to the 3rd, right? Because 3 is the largest exponent. Well, what's the coefficient there? It's actually a 1 sitting there, right? So when I list all these and I've got the guys that are the factors of the constant, -6 on top, and I'm dividing by the factors of the leading coefficient, it's going to be divide by 1, right? So that's not too bad. So what could 1 be? 1 could be 1 times 6, or it could be 2 times 3. Okay, and on the bottom, factors of 1 are plus or minus 1. Okay, and if I simplify that, I know that all of these things divided by 1 are just that thing. So 1 over 1 is 1, 6 over 1 is 6, 2 over 1 is 2, 3 over 1 is 3, and I have to put the plus or minus in front of each of them because I don't know if I'm dealing with a positive root or a negative root, okay? If you wanted to list that out, like actually list it, and I don't know how, I think that on Math Excel, you don't necessarily have a plus or minus button. So if you need to actually list it, well, it's 1 and -1, it's 6 and -6, it's 2 and -2, it's 3 and -3, right? Those are equivalent answers. So if you can't do a plus or minus in Math Excel, then you're going to need to list them all out. All together, I've got 8 possible solutions, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's how listing the possible rational roots works for us. Okay. I'm going to give you one on your own, and then I'm going to work it out, and I'll pause the thing. You can work on it from your side, and we will go from there. So the example is, and again, it's list all possible rational roots. Rational roots or zeros. And my example is g of x equals 4x to the 5th plus 12x to the 4th minus x minus 3. So you might want to just pause it right now because I'm going to pause my side. I'm going to work it out. And the next thing you're going to see is going to be my solution. So go ahead and pause it, do the work yourself, see how it goes. Okay, so I have got my answers. All right, so I listed it out. I figured out that the constant is at the back, -3. So I put plus or minus 1 and plus or minus 3 on the top. I figured out that my leading coefficient is a 4. So on bottom, I put plus or minus 1, plus or minus 4, and plus or minus 2. And then to do all the combinations, make sure of it, you might need to do something like this. Did I do the 1 divided by the 1? Yep, that's a 1. Did I do the 1 divided by the 2? Yep, that's there. Did I do the 1 divided by the 4? Yep, that's a 1/4, right? So you need to list all the possible combinations with the top, with the bottom. One of the ones we did earlier was really easy, right? Because it just had a 1 on the bottom. So those just gave me pretty whole numbers. But now that I've got something with multiple factors on the bottom, it's a little more complicated, right? So the 1 on top should have 3 things, 1, 2, 3, with the different denominators. Got it. And the 3 on top, so let me see here, should have 3 things with the different denominators. 3 over 1, yep, I've got it. 3 over 2, yep, I've got it. And 3 over 4, yep, I've got that one too. So, and remember, all of those are plus or minuses, right? So I've actually got right here 6 numbers, but if I do the plus or minus, there's 12 possible solutions. So if you listed that out, you'd have 12 numbers. So just real quickly, I'm not always going to do this, but I'm going to show you. 1 and a -1, 1/2 and a -1/2, 1/4 and a -1/4, 3, -3, 3/2, -3/2, 3/4 and -3/4, right? So all together I have, if I have to list them, if I don't have a plus or minus, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12 solutions that are possible for my rational roots, okay? And then the idea is once I have this, I'm going to check them and see which ones are actually factors of whatever the polynomial is that I'm working with, okay? All right. So how does that work? Okay, let's scoot forward a little bit and see if we can put the rational root test together with the factor theorem and the remainder theorem that we already know. Okay, so I'm going to do a new example. It'll give us an opportunity to play a little bit with this possible rational root theorem. So I've got x to the 3rd plus 2x squared minus 5x minus 6. I think I already showed that earlier, maybe. Yep. So we said that our possible rational roots, this was one of the examples we did just a second ago. Possible rational roots were, okay, boom, boom. 1 and -1, 6 and -6, 2 and -2, 3 and -3. I do like to list the possible rational roots out if I'm actually going to solve, because I'm going to go through and say, okay, is one of these things going to work for me or not? Okay. So for instance, if I go to put in a 1 here, I'm going to say, well, 1 cubed is 1. Okay, let me do it here. F of 1 is 1 cubed is 1 plus 2 times 1 squared. Well, that's going to be a 2. 5 times 1, well, that's going to be a 5 and a -6. Well, f of 1 is going to be 1 plus 2 minus 5 minus 6. Well, that's a -11 plus a 3. That's a -8. So my question is 1 a solution to this particular equation, this function? And the answer is no, 1 doesn't work. Boom, go away. All right, so that's why I like to list it out whenever I go to actually find which ones work, because I can get rid of that one and not have to worry about the other ones, okay? And I'm gonna say, personally, I like to do my positive roots first, okay? So I did 1, and a lot of times I'll do my roots that are close to 0 first. So I've already done 1, I'm gonna go to 2 and see if it works or not. If that doesn't work, I'll go to 3, and then if that doesn't work, I'll go to 6, okay? If I don't get any of those to work, then I'll start in on the negative numbers. But if I can avoid working with those negative numbers, plugging into stuff, then I'm going to avoid it, right? Okay, so I'm going to check the 2. Is 2 a solution to this guy? So plug in the 2. I got 2 cubed plus 2 times 2 squared minus 5 times a 2 minus a 6. Okay, well, 2 cubed is 8. 2 squared is 4 times 2 is an 8. 5 times 2 is -10. And I've got a -6. So if I do that math, 8 and 8 is 16. And this -10 minus 6 is going to be a -16. And that's going to give me a 0. Okay. So remember that we had that theorem last time, the factor theorem, that said, if I get 0 for a remainder, this guy is a factor. I found one. I found a solution, right? Okay. Got me a solution. Yay. All right. So that means 2 works. Then I'm going to use what we did the other day on synthetic division. And I'm going to say, oh, can I figure out how much the 2 works? And can I prove that it's a factor? And what will I get when I factor out that 2? So let's see. Synthetic division looks like the 2 goes in the box because it's the solution, right? So my root that I'm trying to divide out goes into the box. It's a 2. And then I just pull the coefficients from this guy, right? So the x to the third, remember there's a 1 out there. So I write a 1, a 2, a -5, and a -6. And remember that the idea behind synthetic division is that hopefully this is a faster way for me to do division, faster than long division, right? So the rule is, pull down this first guy, 1, and then multiply and add, right? So 2 times 1 is a 2, and then I'm going to add 2 plus 2 is a 4. Multiply 2 times 4 is an 8, and then I'm going to add -5 plus 8 is 3. 2 times 3 is 6, and then I'm going to add -6 plus 6 is 0. Okay. So indeed I do get, so this is the remainder theorem. And what it says is if the remainder equals 0, then for sure you have a factor, which we knew that, but I'm just plugging in everything we've learned so far on this section, right? So we're going to throw that guy in there. We're going to say, okay, cool. We got a remainder of 0. That means that 2 is definitely a root. And then what I want you to do is I want you to work off of what's left down here at the bottom of the synthetic division. For me, and for many books, what they call that is the depressed equation. Okay. Not depressed like, oh, it's sad or something like that, but depressed as in, hey, we started with x to the third. I pulled out a root. So x to the third turns into the root that I pulled out times something x squared dot, 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 dot. Okay, so the depressed equation is going to be this x squared stuff. And we find that by looking at whatever was left over, okay? So in other words, instead of x to the third, this guy, we depressed him. We pulled out one root. He's out here. That's the x minus 2 guy, right? He's a solution. Okay, we pulled out one root. It was x to the third, so now it's 1x squared. This was 4x squared. Now it's plus 4x because, again, it's depressed. I pulled out one of my x's, right? This is going to be x minus 2 out here because that was the root, the factor that I pulled out. Okay, this was a 3x, but I pulled out one of the x's, so now it's a 3. Okay, so what we're seeing here is this is my depressed equation times x minus 2, and I will get my original x to the third plus 2x squared minus 5x minus 6. So if you want to check that by multiplying it back through, you can distribute this out and see you better get our original, okay? So what we're saying was 2 is a solution, 2 is one of my roots. The factor that 2 came from was x minus 2. And the depressed equation that's left behind is this guy, x squared plus 4x plus 3. Okay, that's what's left behind. All right, but then we go and we look at this and we go, oh, that's a quadratic, right? As soon as I've got a quadratic, I don't have to mess with any of these other roots or rules because I know how to solve a quadratic, right? In fact, I'm looking at this guy and I think it's going to factor, okay? So I've got x to the third plus 2x squared minus 5x minus 6 is equal to, what is this guy as the factors? It's going to be an x and an x. And I need factors of 3 that add up to 4. So it's a plus 3 and a plus 1. Okay, x plus 3, x plus 1. And then don't forget, oh, I'm so sorry. Bless me. Don't forget that I pulled out this x minus 2. It's one of the factors, right? Because the solution was x equals 2. So don't forget that he's in there. All right, so let me scoot this up. I got good stuff here. So now we have this thing factored into 3 little binomials. They're all linear, and I can find my solutions. And remember, solutions are the same as roots, are the same as zeros, are the same as x-intercepts. Those are all words when we're solving a polynomial that basically mean the same thing, and we get them all by y equals 0, right? By setting them all equal to 0 and solving for x. So what I'm going to have here is 0 equals x plus 3, x plus 1, and x minus 2, okay? And now that I have that, I take each of them. And this part, I mean, you guys have been doing this since the first day of class, right? So hopefully this is good. X plus 3 equals 0. X plus 1 equals 0. X minus 2 equals 0. Okay. Solve this guy. We're going to subtract the 3. X equals negative 3. Solve this guy. I'm going to subtract the 1. Those are going to go away. X equals negative 1. And solve this guy. I'm going to add the 2. X equals 2. All right. So again, we got the guy that we pulled out through using synthetic division. But we also got 2 more solutions. Okay. X equals negative 3. X equals negative 1. Let me go back over here. So we have our roots, we've got our solutions, we feel good, we're done, we solved this particular polynomial for x, but let me go back in here and see. Remember we had these possible rational roots? We figured out that the 2 worked, we got him. We figured out the negative 1 worked, right here, we got him. And we figured out that the negative 3 worked, we got him. Okay, so all 3 of those rational roots were in my list, and they're going to be. If the solution is a whole number or a fraction, it's going to be in your list once you do this possible rational root thing, okay? So that's the nice part about this. It will narrow my choices. So I don't have to check, what about if x equals 4? What about if x equals 5? What about if x equals 7? I don't need to check. It's not a million possibilities. So yeah, it's still 1, 2, 3, 4, 5, 6, 7, 8 possibles that I had to check. I really only substituted in 2 before I found the one of them, right? But it's not a million numbers. Like, it really helps narrow down my search using this possible rational root test, okay? So that's the idea behind what we want you to do here and be able to solve these polynomials. All right, the other thing I want you to notice is this. The original equation that we were working with had a third power, right? X to the third. And we ended up with 3 solutions. 1, 2, 3 solutions. So in general, if you have a leading exponent in, you will have n roots. Okay, what does that mean? It means that whenever I started working with this problem and I saw x to the third and the 3 was my biggest possible exponent here, it's the leading exponent, I knew it's a 3. I knew I better have 3 solutions. 1, 2, 3. Okay, if they're all rational, then that's just wonderful for me. Okay, unfortunately, they're not all going to be rational, but if they are, then they're all going to be in that list I just made. So we're going to work one that's not all going to be rational, okay? But we'll still end up with the same number of solutions as what my leading exponent is. So we're going to see that. Okay, here's my example. X to the third plus 7x squared plus 11x minus 3. That's my f of x. And the directions for a problem like this is going to say something like find all roots of the polynomial, something like that. I gotta find all the possible roots, or first I'm gonna find the possible rational roots, and then I'm gonna find all of the roots, okay? So let's start with the rational root test, okay? Okay, it says, one more time, here's my constant, here's my leading coefficient, it's a 1, right? The coefficient is a 1. So I'm going to list all the possible factors of the 3. Well, 3 is prime, so that's a 1 and a 3. And I'm going to divide by all the possible factors of the leading coefficient. Well, that's just a 1, so it's a plus or a minus 1. So let me list those out. It's nice that it's divisible by 1 here, being divided by 1. So I've got a 1, a negative 1. I've got a 3 and a negative 3. So there's 4 possible roots here. That's it for the rational roots, right? Okay. So what about that? Well, I'm going to cheat just a tiny bit. I happen to know that negative 3 is the one that works. We could sit here and go through and use the 1 and use the 3, but the negative 3 works. Okay, so we're going to check that and make sure. So let's find it. F of 3 would be 3 cubed plus 7 times 3 squared. It's just, I'm doing that to save time, right? Plus 11 times 3 minus 3. So let's do that. 3 cubed is 3 times 3 is 9 times 3 is 27. Oops, and it's negative. I'm sorry. Let me stick in a negative for all of those 3's. Negative 3. Negative 3. All right. So 3 times 3 is 9 times 3 is 27. It's a negative times a negative times a negative. So this is negative 27. All right. And then I've got negative 3 squared. Well, that's going to be a positive 9. Positive 9 times 7 is a 63. Okay. And then I've got negative 3 times 11. Well, that's negative 33. And then I've got minus 3. Okay. And what we're going to see here is, here are my negatives. Okay. If I add these together, negative 27 and negative 3 is negative 30. Negative 30 plus negative 33, that's negative 63. And I've got a positive 63. So sure enough, that's a 0. Okay, so what this tells me, remember, is that -3 is a root or a 0. Okay, so I'm going to be able to factor out the solution that has -3 in there, and it's x to the third. So once I factor that guy out, I'm going to end up with a quadratic equation, right? So we're going to use our synthetic division. Yay. I really like synthetic division. It's pretty nice to deal with. What number goes in the box? Well, that's my root. So it's going to be a -3 over here. And then remember, all I do is pull down the coefficients and make sure that there's not a gap in there in the exponents, right? I've got an x to the third, that's a 1. I've got an x squared, that's a 7. I've got an x, his coefficient is an 11. And then I've got a constant, which is a -3. Okay, so make sure that all of your x terms are provided for, right? If it's not, if I was missing this 11x, then I would put a 0 as a placeholder there. Okay. Remember how to do your synthetic division, pull down a 1, and then we just multiply. -3 times 1, -3. And then we add. 7 plus -3 is a 4. Then we multiply. -3 times 4 is a -12. And then we add. 11 plus -12 is a -1. And then I multiply, be careful. -3 times -1 is a +3. -3 plus 3, I add, it's a 0. Okay, so indeed, I get a remainder of 0. Yay. That's good stuff. We like that. So we know that this guy came from x plus 3, right? So my function is, let me write it here. Function is, we have an x plus 3 that we factored out. That's what we just did when we did the synthetic division. And then this guy right here is going to be my depressed equation. All right, depressed equation, which again means we started with x to the third. It's not always x to the third, but x to the third is one that we like to do a lot. Okay, so this was x to the third. We depressed it. We pulled out one of the solutions, so it's x squared now. This was 4x squared, or it was x squared term. Now it's 4x. And this was my x term. Now it's just a constant, -1. Okay, so I've got x squared plus 4x minus 1. Okay, and it would be really nice if this factored, but unfortunately, this guy will not factor. So the last one that we did, it factored, and that made my life pretty easy, right? But this guy's not going to factor. So, oh man, now what? Okay, well, the now what is, now I have a quadratic equation that I need to solve for x, right? I need to find my two solutions. By the way, the fact that it doesn't factor tells me, let's go back up here real quickly, that I'm not going to get one of these nice, pretty whole numbers, right? If I got a nice, pretty whole number, it would have factored. So I'm going to get not a rational root here, okay? So what we're going to do is we're going to go off to the side and we're going to solve this guy, okay? We're going to set him equal to 0 and solve him, okay? Well, I can't factor him, so instead, my other thing that I can do whenever I've got a quadratic is I can do x equals -b plus or minus the square root of b squared minus 4ac all over 2a, right? That's my quadratic formula. Have that guy in your back pocket somewhere. Yay. Because we might need to dig him out. So if I'm going to use this, then I need to know what's what. So I've got an a equals 1 here. I've got a b equals 4 here. And I've got a c equals, be careful, it's a -1. Okay. There are the things that I'm going to substitute in. Okay. So to solve this guy, I'm going to come over here in the quadratic and I'm going to plug in. X equals negative, my b is a 4, plus or minus the square root of b squared. So b was a 4 squared minus 4 is in the formula. Sorry about that. The a was a 1 and the c was a -1 all over 2 times a, well, the a was a 1. All right, there we go. Scoot that up. All right, and then it just becomes a matter of how good are your quadratic function skills, right? So how good is your arithmetic, basically? So here we go, x equals -4 plus or minus. I'm gonna simplify this guy. 4 squared is 16. I've got a -4 times a 1 times a -1. Negative and a negative is gonna be a positive. 4 times 1 is a 4, okay? All divide by 2 times 1 is a 2. Now, hopefully we kind of see where the issue lies, because if I simplify this just one more, I've got -4 plus or minus the square root of 20, right? All over 2. And the square root of 20, is that a perfect square? Is 20 a perfect square? In my head, I'm hearing, no, Dr. Webster, it's not. And you're right. That's why my rational roots aren't going to work here, because whenever I get to doing this, I've got -4 plus or minus 20 is 4 times 5, right? So that's 2 times 2 times 5. I can pull out 2 times 2 out of the square root. So -4 plus or minus, this is going to be 2 square roots of 5 all over 2. Well, look at that square root of 5 sitting in there. That's kind of yucky, right? So this will reduce just a tiny bit more, but pretty much we're done. We have 2 not rational solutions is what this means. So pull out the 2, pull out the 2, pull out the 2 out of each of these terms. I get -2 plus or minus square root of 5 all over 1. I don't have to divide something by 1. There's my answer, okay? It's irrational. That's just a fancy way of saying we're stuck with like a square root or something like that. If I punch this on my calculator, it's going to be a decimal that just goes on forever and ever and ever, right? So it's not rational. All right. But what I want to do is I want to make sure we know what our solutions are. Okay. So let's go back for just a second and let's talk about our roots. My roots for this thing were, this was just the quadratic part of it, right? That I was solving. Let's go back here. We pulled out -3, right? It was a 0. So I've got x equals 3 as a solution. That's the one I did synthetic division on it. I've got x equals -2 plus the square root of 5. And I've got x equals -2 minus the square root of 5. Okay, see how I split this up? The plus or minus means that I've got 2 solutions there. Okay, one of them was rational. It was in my list of possible rational roots. This guy's irrational. This guy's irrational. But my question is, how many solutions did I get? 1, 2, 3, right? 3 solutions. So if I go back and look at this, remember it was x to the 3rd. I should have 3 solutions. Do I? Absolutely, I do. So that's good. That means that what happened was what was supposed to happen. I like it. Okay. So I'm gonna say real quickly, here's a little theorem, and you can find it in your book somewhere if you're looking. Whenever I have an irrational number like this with the square root of 5, I'm also going to have the negative square root of 5. Those are called conjugates, okay? This also happens whenever I have imaginary numbers. So hopefully somewhere in your background, you've talked about imaginary numbers. And I'm going to do one in just a second where we work that out and we see the imaginary numbers. But this process where I get a plus and a minus also works with the imaginary numbers. So we are going to do one example. It's making this video a little bit long, I'm sorry. But we are going to do one example with the I on it. And so once I talk about imaginary, I'll probably like stop the video, do some work, you can do some work, and then I'll pick it back up and then we'll go some more. Okay. So what do we know about imaginary numbers? Imaginary numbers happen when I have something like the square root of -4, right? I cannot find any real numbers that multiply by itself. Remember, the square means the number times itself. So you get 2 of them. and it will give me a -4. Okay, if I had square root of 4, sure, that's the square root of 2 times 2. I can absolutely pull 2 of those 2's out and just get a 2. That's fine. But when I have this -1 in here, it's a problem. So what we end up doing is we end up saying, hey, I'm going to split this up into the square root of -1 times 2 times 2. And the reason I do that is because I just showed you. I know how to deal with that, right? Pull these guys out. They go out in front. This is 2 times the square root of -1. Cool. At least I can do something with it, right? But in math, we don't like leaving things. This is technically an undefined thing, right? This is no real solution, okay? And we don't like that. So what an imaginary number is, deals with this guy right here. Imaginary numbers. And it's just something that we defined. I equals the square root of -1. That's what we know, okay? So if I have the square root of -1 here, I'm going to substitute in an I. So this is technically, if I do square root of -4, 2i, okay? So what we do is if we see a negative inside of the radical, and it's an even root, a 2, a 4, a 6, that kind of thing. We're going to pull the I out first, and then we're going to deal with whatever's left over inside of there, right? And that's where imaginary numbers come from. It's basically mathematicians saying, we don't like having to say, I can't do anything with that. So I'm going to make up a number that is I, and we're going to call it that, and I'm going to use it. Something that we might need to know is, what if I squared this guy? It would be the square root of -1 squared, right? Well, on the left-hand side, that's just I squared, no problem. But on the right-hand side, what happens here? The square and the square root are opposite operations, right? So they will reduce out or cancel each other is what I hear people say, okay? If those two go away, then what's left over is that -1. So we need to define for our notes, what is I, square root of -1, and what is I squared? Well, that's a -1, because eventually we're going to do some stuff and we're going to have to square that I, and we're going to need to substitute it as well, okay? So this is where we're headed. So I'm going to give you an example, and then I'm going to pause, and I'm going to let you do some of the work. I'm going to do some of the work, and then I'll put it back on. We'll talk, and we'll go from there. Okay. All right. So again, in the interest of making this video not 2 hours long, I'm going to do some pausing and working on my own. So here's my example. And it will be solve for x is my directions. Find all the x's possible, basically. F of x equals x to the 4th minus 6x squared minus 8x plus 24. Okay. And I want you to note right up front, my biggest exponent is a 4, which tells me when I'm finished, I better have 4 solutions. Okay. So I'm going to pause it. I'm going to do the rational root test. And you pause it and see if you can find what I'm about to show you. Okay, so here we go. All right, so hopefully you listed out all the factors of 24 on the top and all the factors of a 1 on the bottom, and you got a 1, a 24, a 2, a 12, a 3, an 8, a 6, and a 4. When I count all those up, it's 1, 2, 3, 4, 5, 6, 7, 8 of them. Times 2, because one's a positive and one's a negative. I've got 16 possible solutions here in my list, right? Which seems like a lot, but again, it's better than having to check every stinking number, right? Like at least I know I don't need 5 and I don't need 7 and I don't need 9, 10, or 11. So it narrows the field. That's what we're after, okay? And now what I want you to do is I want you to pick a couple of those and see which one works. So try 1, try 2, try 3, see if one of those will work for you. And the way we're going to check it, and I'm going to do f of 2. Okay, the way we're going to check it is by plugging in the 2, right? So let's do that real fast together, actually. 2 to the 4th, 6 times 2 squared, minus 8 times 2 plus a 24. 2 times 2 is 4 times 2 is 8 times 2 is 16. 2 squared is 4 times 6 is a negative 24. 8 times 2 is a negative 16 and a positive 24. Okay, so I'm looking at it going, hey, I got a 16 and a negative 16. I got a negative 24 and a positive 24. That is indeed 0, right? So 2 is a 0. That's what this tells me. Okay, that's how I read that. I plugged in 2. I got out 0 for my y. 2 is a 0. That's one of my solutions. Okay. Well, that's all great and dandy, but remember this was x to the 4th, so I need to do something to reduce this down. So what I'd like for you to do, and again, I'll pause it. I didn't do that right then, is I'd like for you to do the synthetic division with the 2. So I've got a 2 in the box, a 1, a negative 6, a negative 8, and a 24. And I'm going to pause mine real fast, and hopefully we come up with the same thing. When you got your answer for the synthetic division, push pause again or unpause it, and we'll go. Oops, look at what I did. I messed up. There was a 4, there was a 2, and there was a 1, but I need a 0 in there for the x to the 3rd guy, right? And I knew it as soon as I got going. So here we go. Try again. Put in the 0. So what you should be doing, sorry about that. Not that guy. You should be doing synthetic division with 1, 0, negative 6, negative 8, and 24. Because I didn't have an x to the 3rd guy, so I need to put a placeholder there. So try that guy with your synthetic division. All right, so I did my synthetic division, and I have this guy, my depressed equation, is going to be, I'll call him g of x. X to the 3rd plus 2x squared minus 2x minus 12. That guy. Now I need to start all over dealing with this guy. So if you want to, you can start back over with your list of possible rational roots. But basically, I know that I've got a 12 here and a 1 here. So it's basically the same possible rational roots, right? I just don't have the 24 anymore now that I'm looking at this depressed equation, because the constant term is a 12 instead of a 24. So what I'm going to do is I'm going to plug in 2 again, okay? Because I happen to know 2 is going to work a second time. So let's do that real fast. Sorry if I'm rushing you. I'm just trying to get through so your video is not as long. So if you need to pause and make sure you can substitute in on your own, then go ahead and do that, okay? So I've got g of 2 is 2 cubed is 8. 2 squared is 4 times 2 is 8. Minus 4 minus 12. Again, this is 16. This is negative 16. So lo and behold, it is a 0. So 2 is a 0 again. Okay. So if we talk about how many times 2 is a 0, it's a 0 at least twice, right? So once here it worked, and once here it worked. So it has multiplicity of 2 is what we call that. Or you could just say 2 works twice. 2 works twice. Okay. That's the way I think about that. Okay. So I've got that guy. I need to depress the equation again, right? Because this was a 3. Let me find the G guy. Here he was. He's a 3, and I need to go ahead and depress him. I'm going to use 2 because I know it worked. I'm going to put that in my synthetic division. 2. I've got a 1, a 2, a negative 2, and a negative 12. And I've got the 3, the 2, the 1, and the 0 all accounted for. So I'm going to do this synthetic division. All right. So I'm going to pause. You can pause. Go ahead and do your synthetic division. See what you get for another depressed equation. Okay, again, I get remainder 0. So indeed, it does factor out. This was an x to the 3rd guy. So my new depressed equation. And I already used an f and I already used a g. So I'm going to say h of x equals x squared plus 4x plus 6, right? Because it was x to the 3rd up there. Now it's x squared because I pulled out another root. So I depressed it one more time. So now I've got a quadratic. Unfortunately, this guy is not going to factor, so I need to solve him, and I'm going to solve using quadratic formula. Okay, so that's where I am. So one more time, I'm going to pause it. I'm going to do the work because I feel like you guys can do the work for the quadratic formula, and then I'll come back one more time. Okay, whew. So I got my A is 1, my B is 4, my C is 6. I set up my quadratic equation. I plugged it in and I'm working along. And what I see is this. Inside of this square root, I'm doing 16 minus 24. Okay, which is going to be a -8. And when I see that in my mind, things start triggering. I can't take the square root of a negative number. That's not a real number, right? It's not no solution. In the olden days, then we called it no real number. And now we're going to use imaginary, right? So in my head, I say, oh, that's an imaginary solution. So I need to get my answer here. So we're going to have to dig in and find our eyes for this one. So hopefully you at least got to this point. You plugged in properly. You've picked out your A, your B, and your C. And now we just need to deal with this guy. So off here on the side, I'm going to deal with square root of -8. And I'm going to say, look, that's a -1 and a 2 times a 2 times a 2, right? That's what 8 is. Okay. Well, when I do that, I know the 2 and the 2, because it's a square root, those will pull out. And I know that this -1 is an I. So what I'm going to have is a square root of 4 is 2. Square root of -1 is I. And then look at this 2 that's left over. He's just sitting in the square root, right? He's got to stay in the house. That's what I say, right? You got to stay in there, buddy. Okay, so there he is. So square root of -8 is the same as 2i square roots of 2. So I'm going to make that substitution. X equals -4 plus or minus 2i square root of 2 all over 2. Okay, we're almost there. Remember that when I have an even, like a 2 out here, I can reduce it on the top and the bottom. So this is going to be, but it has to come out of all of the terms, -2 plus or minus I square roots of 2, and divide by the 2 becomes a 1. So that guy just goes away, right? So I just have -2 plus or minus I square roots of 2. And what I want you to see here is whenever you have an imaginary number, you have that plus or minus. And remember that what that means is you are going to have, I'm going to put it right here. You are going to have the positive and the negative, two solutions. So when I go to imaginary numbers, there's going to be a +1 and there's going to be a -1. Always. And it's very rare that Dr. Webster says always, but this is one of those times. Okay, I always get a plus or minus, just like whenever unless this guy completely goes away and makes a 0, we're going to have 2 roots here. Same thing whenever we had the radical earlier, right? It was like square root of 5 plus the square root of 5 minus the square root of 5. That guy's going to stick around. I get 2 solutions, plus and a minus. So that means I've got x equals -2 plus I square roots of 2. That's one of my solutions, right? I've got x equals -2 minus I square roots of 2. Okay, that's my 2 solutions from the quadratic, right? But I'm not finished. Remember that way up here we had 2 works twice. That means I've also got x equals 2 and I've got x equals 2. 2 worked twice. So I've got 4 solutions. Okay, that's what they look like, 4 different roots. This one happens to be a repeated solution. And that's when you're going to see in the book or whatever that multiplicity thing. It happens multiple times. So its multiplicity is a 2. Okay. And I know this is turning into a really long video, but hopefully it really explains to you what's going on in all the different cases so that now hopefully you can do this homework. All right, if you have questions, let me know. I'm sorry it's so long. I tried to make it as fast as I could. Have a great day and let me know if you have questions. Thanks. Bye.